In this video, we will be looking at how to find the equation of a parabola in a word problem. So, a park has a parabolic arch at the entrance. The arch spans a total of 22 meters and is 20 meters high in the middle. So from this, the 22 meters is the width of the base. So that's how far apart you might say that the zeros are. And then 20 meters is that optimal value, which relates to the vertex. So it says sketch this relationship, then determine the equation of a quadratic relation in standard form, which could model this relationship. So let's start off with our sketch. So we can say that the base of the arch is at the origin because it didn't specify anything else, and there's my arch. The distance between the two bases is 22 meters. So if I'm making one of my zeros at 0, then the other one would be at 22. It also says that the maximum height is 20 meters. So right here, we have 20 meters for where our vertex is. Now, that means we have the y-coordinate of the vertex. If I want to find the x-coordinate, well, I already have my 0, so I can go halfway between 0 and 22, which is 11. So now I have two zeros and I have my vertex. My goal is to get my equation in standard form. You can actually start from factored form, find that equation, find your a value, and then turn it into standard form, or you can do vertex form because you have the vertex. I personally think that if you have factored form, it's easier to expand that than vertex form. So when I'm given the option, I'd rather choose my factored form. So y equals a x minus 0 and x minus 22. Now this x minus 0 is pretty useless in that anything minus 0 is itself. So I'm going to rewrite this as a times x minus 22. Now, I've used my zeros, now I can use my vertex as that random point to help me find my a value. So instead of y, I'm going to put 20, and instead of x, I'm going to put 11. And now it's just a matter of cleaning it up. So we have 11 times negative 11. And remember, when you multiply those two numbers, that's going to become the coefficient of a. So negative 121a. And then I can divide both sides by negative 121, and your a value is negative 20 over 121. And there we are. Now we can put it all together into our factored form. And because one of our x-intercepts is at 0, it's really easy to distribute this because it's just a single term being multiplied into your bracket. So let's go ahead and do that. And we're going to keep the fraction and just deal with it. So x times x is x squared, and then a negative times a negative is positive. And then 20 over 121 times 22. When you reduce it, it's going to be 40 over 11x. Now, in this scenario, you have your standard form, but y and x don't actually mean anything to us. So because it is a word problem, you have to put let statements. I personally like to do all of my calculations, and then at the very end, I'll put some meaningful variables and then replace them for my final equation. So we are dealing with an overall height and a horizontal distance from the base. So let's say let h represent height, and it's in meters. Let d represent distance or horizontal distance from base. So then we have h equals negative 20 over 121 d squared plus 40 over 11d. And that way we just have variables that actually mean something to us. And you could have kept x and y if you wanted to, but you would need let statements telling me what they represent. All right, Let's try another one, but this time we're going to be given a table of values for our information. So the relationship between the selling price of a bag of cotton candy S and the daily profit P of a cotton candy vendor at the fair is illustrated in the following table. Sketch the relationship, then determine the equation of a quadratic relation in vertex form, which could model this relationship. So I already have variables in here, S and P, so I can use those throughout. Now, looking at my table, these are the prices for the cotton candy, and these are my profits. So I can see when the selling price is 0 and 4, my profit is in the negatives. And then looking at it, I kind of want to find my vertex because I do need vertex form. So it looks when the selling price is $2, we have a maximum profit. So I will highlight this because it will be important for my vertex form. So let's do a little sketch here. It is going to be very rough, and I am going to include negative values for my profit. So let's say we start at negative 80 here. Our maximum is 160. The maximum occurs at 2. And I'm just going to use that 0 and 4 because those are when those negative 80 profits occur, where you're actually losing money. So I'm not actually plotting all of the points. I'm really just estimating everything else between the key points that I have drawn. Now, we need vertex form, so I'm going to use my vertex and I'm going to put it into vertex form. Now, you can start off by using S and P right away, or you can use X and Y and then put S and P at the end. But I'm just going to use S and P from the very beginning. So S is kind of like our X coordinate and P is like our Y. So I'm going to start off, instead of Y equals, I'm going to write P equals. I don't know my A value, and then typically we would have X minus the X coordinate of the vertex, but instead of X, I'm going to put the selling price. And our vertex is at 2, so I'm going to write S minus 2 all squared, and the maximum profit is 160. Now, I can use any other point in this table to plug in for S and P to solve for A. So you have lots of freedom here. And it doesn't matter which point you choose because they're all going to give you the same A value. I'm just going to pick this first point. So instead of the profit, I'm going to put negative 80. And instead of the selling price, I'm going to put 0. And remember, whenever you're dealing with vertex form, this optimal value is going to be brought to the other side. It's not going to get collected with the A. So I have negative 80 minus 160 equals, and now I'm going to do 0 minus 2, which is negative 2. Negative 80 minus 160 is negative 240. And please remember, a negative number squared will always become positive. So negative 2 squared is 4A. And now we can divide both sides by 4, and that will give us negative 60 equals A. And now that we have everything we need, we can put it all together. So negative 60, S minus 2 squared plus 160. And that's your equation in vertex form, and you are done because you don't have to put it into standard form, and we have the appropriate variables. And again, in this scenarios, you don't need let statements because the table of values already had variables picked for you. All right, let's try one more. A golf ball is hit off a tee 10 centimeters off the ground. The ball reaches its maximum height of 25 meters at a horizontal distance of 90 meters from the golfer. Determine an equation in standard form to model this scenario. So, even though it didn't state to draw a picture, you always want to start with a picture. All right, so we are told that the ball is hit off a tee that is 10 centimeters off the ground. If you notice, all the other dimensions are given in meters, so we should probably rewrite that 10 centimeters in meters, which is 0.1 meters, because 1 meter is 100 centimeters. Okay, so here is our y-intercept, 0.1 for when the ball was hit off the tee at the very beginning. And now the maximum height is 25 meters, and it occurs 90 meters away. So this is what our parabola should look like. So here we have the vertex, which is 90, 25. and we have a random point, which is our y-intercept in this case, which is 0, 0.1. So with that 10 centimeters, there are two things you have to remember. First of all, you have to put into meters. And second of all, it is a coordinate and the x value here is 0. So let's go ahead and put the vertex into vertex form. So here you don't have the option to do factored form because I don't know anything about my zeros. So y equals a x minus 90 squared plus that optimal value of 25. Now we can go ahead and put 0.1 for y and 0 for x. And just like before, bring the optimal value over first so that we do 0.1 minus 25. And then 0 minus 90 is negative 90. And now we can do our subtraction to get negative 24.9 equals, remember negative 90 squared will be positive, and it will be 8,100a. And then we can divide both sides by that 8,100. Now when you plug this into your calculator, you will get a long run-on decimal. And in a question, I will specify how many decimals I want you to round it to. But in this case, we're going to put quite a lot because if you don't, you lose quite a bit of accuracy and your y-intercept won't match. So I'm actually going to put all of this for my a value. And even so, I'm still rounding. Now, when I want to put this into vertex form, I'm going to write out my x minus 90 bracket out twice instead of writing x minus 90 squared because I know I'm going to turn this into standard form and I don't want you to fall into the trap of writing x minus 90 squared and thinking it's okay for you to just write x squared minus 90 squared because that is wrong. You need to do your full distribution or your FOIL. So let's go ahead and do that. So x times x times negative 90, and then same thing again, and then negative 90 times itself. Now we can distribute this decimal in. You could also collect your like terms in the brackets first and then distribute it. And you know what? I'm just going to do that so that my numbers don't get too ugly. So that I have negative 180x. Now let's get rid of those brackets by distributing negative 0.003074 in. And then here, be careful, negative times negative is positive. And then when we do the multiplication, you get 0.55332x. And then negative 24.8994 plus the 25. Now we can finish off and just collect our like terms. And I know it looks quite ugly. And the process is the same as always, it's just those decimals can be quite overwhelming. Now, if I had given you a value as a fraction, I would expect you to keep everything in fraction form. In this case, we can keep the decimals because our y-intercept was a decimal. So here we are. And if you look at the y-intercept, it pretty much matches that 10 centimeter off the ground starting point. If we had rounded more and just kept it like 0.003, things wouldn't have matched. And now let me put my let statements and put some meaningful variables. So I'm going to say let h represent the height and let d, oh, and that's in meters, let d represent the horizontal distance. And that is also in meters. And then we can finish this off and write h equals negative 0.003074 d squared plus 0.55332d plus 0.1006. And then that would be your equation. So for all three of these examples, the process of finding the equation of the parabola is the same as with regular knowledge questions. The only difference is that you have to pull away the key information from the wording in the problem. So when you see the word maximum or highest, you know you're talking about the vertex. When it's a starting point, like when a ball was, or at what height the ball was hit from, that would be your y-intercept. If you're talking about when something lands or how far apart arches are, that's your zeros. And then that is it for modeling quadratics.